Nana showed this exact pattern. Spotify does the same thing. Google Cloud runs their backend. But when AWS has a better offering for a specific service, they reach across and use it. No drama. No grand architecture decision, just a practical call. The interesting part isn't that it works, it's what happens next. Because in 2026, your app doesn't make one cross-cloud call. It makes dozens, and that's where things get complicated fast. Think about why it's 50. Your app needs GPT, that's only available through Azure. Exclusive deal with OpenAI. It needs Gemini, only on Google Cloud. It needs Claude, that's AWS Bedrock. Each provider means a separate SDK, separate login system, separate billing meter. Nana showed how painful just 2 clouds get. Duplicate Terraform configs, networking that doesn't translate across providers. Now picture that times 4, and here's what really breaks down. Every one of those calls might be sending customer data to a different country, under different compliance rules. Nobody's tracking which model made which decision. Your audit trail just scattered across 4 providers that don't talk to each other. Each of those providers built walls around their best models. You can't run GPT anywhere except Microsoft's infrastructure. You can't access Claude outside Amazon's ecosystem. These aren't suggestions, they're exclusive partnerships. So when your product team wants the best language model for customer support, and your data team wants the best vision model for document scanning, and your security team wants a different model entirely, congratulations. You just committed to 3 separate cloud contracts, 3 billing systems, and 3 completely different authentication setups. Nobody in the boardroom planned this. Your AI roadmap planned it for you. Nobody publishes a universal price list for AI inference. Each cloud negotiates its own deal with the model provider, bundles in its own compute markup, and charges differently depending on region. So your finance team runs the same prompt through the same model on 2 different clouds and gets 2 completely different line items on the invoice. Now multiply that by 50 calls per user session across 3 providers. Your cost forecasting just broke. But the money problem is actually the easier one to fix. The harder one is what happens to the data flowing through those calls. Your main application sits on AWS, but when it calls Azure OpenAI for a GPT response, that customer input, maybe a support ticket, maybe a medical question, leaves your AWS environment and lands in whatever Azure region handles that request. When it calls Google for Gemini, same thing, different destination. Nana's original example was one Azure AI call from an AWS app. Clean and simple, but at 50 calls across multiple providers, your customer data now sits in infrastructure governed by different countries, different privacy laws, different retention policies. And here's what catches most teams off guard. Your compliance documentation probably still says all customer data stays within your primary cloud. That was true 18 months ago. It stopped being true the moment your AI strategy went multi-provider. The audit trail doesn't just double, it fragments across systems that were never designed to talk to each other. Picture a customer complaint. They say your AI gave them bad advice. Your legal team needs to know which model generated that response, what data it saw, and whether it was the same model you tested last month. On AWS, your logs sit in CloudWatch. On Azure, they're in Monitor. On Google, they're in Cloud Logging. 3 different formats, 3 different timestamp standards, 3 different ways of identifying who or what made each call. Nana walked through this exact friction with authentication. AWS uses IAM roles. Azure uses service principals. Google uses service accounts. Each one handles identity differently. Now multiply that by 50 AI calls per user request, each potentially hitting a different provider. Your audit trail doesn't just have gaps, it has chasms. And here's what makes AI governance different from regular cloud governance. A traditional API returns the same output every time. AI models don't. The same prompt can produce different answers depending on the model version, the temperature setting, even the time of day. So when a regulator asks why your system denied someone's loan application, you need more than logs. You need to know which model version was running, on which provider, with which parameters. Communities are already raising alarms about AI agents operating across cloud boundaries without unified oversight. The teams solving this build one internal gateway that every AI call passes through. One place for auth, one place for logs, one source of truth. This is the pattern that stops the bleeding. Remember the problem? Your app on AWS needs to call Azure OpenAI for GPT, Google Cloud for Gemini, and Bedrock for Claude. Without a gateway, every team that touches AI builds their own authentication, their own retry logic, their own cost-tracking spreadsheet. Nana showed exactly how painful this gets. Different SDKs, different security models, completely different ways of doing everything. Multiply that across 50 AI calls, and your engineering team spends more time managing connections than building features. The gateway flips that equation. Your application developers write to one internal API. They never think about which cloud answers. Behind the scenes, the gateway handles something most diagrams won't tell you: credential rotation. Each cloud provider expires tokens on different schedules. Azure uses service principals. Google uses service accounts. AWS uses IAM roles. One gateway manages all three identity systems, so your developers never touch a single cloud credential. But the real power is what happens when things break. Say Azure OpenAI goes down during a traffic spike. Without a gateway, your application crashes and someone gets paged at 2 in the morning. With one, the gateway reroutes that request to the same model running on Bedrock. Your users never notice. Your on-call engineer keeps sleeping, and every single call, successful or failed, rerouted or direct, lands in one log. One place to audit, one place to answer the question from the last scene. Which model made that decision, and what did it cost? Most teams want to jump straight to the top. They want failover and redundancy before they even know how many AI calls they're making. That's like buying insurance on a house you haven't inspected. The order here isn't arbitrary. Tier 1 takes hours, not weeks. But skipping it means your gateway route's blind. You're centralizing calls you can't even list. And remember, Nana walked through what happens without centralized control. Different SDKs, separate authentication systems, duplicate configurations for every provider. That operational overhead alone can double your cloud bill. The gateway solves that before it gets worse. Now, Tier 3 is where the real leverage lives. When you can swap one model provider for another without changing application code, you've broken the lock-in economics. Providers know most companies won't switch once they're integrated. That's how they price. When you can switch, you negotiate from strength. But here's the honest part. If your company has fewer than 500 engineers, you might not need Tier 3 at all. Multi-region on a single cloud gives you 90% of the resilience at a fraction of the complexity. Match the tier to your actual scale. That checklist on screen? It sounds simple, but here's why it matters so much. Most teams we've talked about, Netflix, Spotify, Uber, they didn't start with fancy gateways or failover systems. They started exactly where you are. One inventory, one honest look at what's calling what. Because once you see that your apps are already making dozens of ACE-I calls across 3 or 4 providers, you can't unsee it. And that clarity is what separates teams who control their cloud costs from teams whose bills just keep doubling from operational overhead they never planned for. The full provider comparison, which cloud wins for each of the top 5 ACE-I use cases, and what it actually costs, that's on the blog, linked in the description. Thanks for going deep with us. If this saved you from even one surprise on your next cloud bill, share it with your team. We go deep like this every week.